Hey guys, welcome back to the shop. We're going to begin our next job, which is going to be machining a new spindle for a jet wood lathe. So this belongs to one of our viewers named Dave, and he says this is out of a model JWL 1642 EVS jet wood lathe. And the problem that he says that this spindle has is that it's bent, and on top of that, you've got some gall threads here on the end that your chuck screws onto. So he just wants a new one machine. That is what we're going to do. This is going to be some good lathe work and mill work here, and I plan on using our Precision Matthews lathe and our KBC mill to get this done. We're just going to do this all manually, okay? I've got a piece of 2 3/4 4140 that we're going to cut and use to machine this spindle, and we went with the 2 3/4 because of this diameter right here being right around 2.7, I believe. Let's see what this was. I can't remember. Yeah, so right around 2.7. So the thread in here is going to be 1 1/4" 7, and this is a standard thread for things like chucks and face plates that screw onto the end of these smaller lathes like that. All right. And then we have, then going down the line, we have a, I think that was a 35. Let's switch that over to metric there. So we have a 35 millimeter bearing journal there. This is an undercut. You've got 4 holes that's drilled and tapped there. This is going to be where the gears or the pulleys go. That's going to be 35 mil. And then we've got a 25 millimeter journal here. Now this thread here on this end is going to be a metric 22 millimeter by 2.5 thread. And I believe this is 19 out there on the end. Yep. Overall length is right at about 13 inches total for this, okay? So the other thing to take consideration for this is the end of here is machined for a #2 Morse taper. I've got this is a #2 Morse taper drill bit just to use for, we can use this for the taper and the size reference, but it's actually made where you can put a center in there, and that's a commonly used way to use a spindle. Same thing on a metal lathe. These spindles are always machined on a taper. For the machines that I use, they're typically either a #4 or #5 Morse taper, so that you can stick a center in there and run between centers. So we'll have to get that drilled and get it bored for a #2 Morse taper. We also have, I grabbed this for reference, and then I do have a reamer made for a #2 Morse taper as well that we can use if we need to kind of ream that out once we get it bored, try to slick up that bore in there. The rest of it is just a 10.2 millimeter hole that's drilled all the way through it there. I don't believe this serves any other purpose other than just having a clearance hole to go through there, but we're going to be drilling that out to 10.2 millimeter. So I believe that kind of covers everything there. These are just that's the bearing. This is a collar that slides up on this area right here. Okay, and then of course the chuck. This is the chuck that he uses for the lathe there as well. So that's it. How about we get started on this guy? Let's get a length on this guy. I'm going to use my 24-inch Starrett vernier calipers for this. Feels pretty square on the faces there. I'm measuring 12.9 inches. So our finished end length is going to be 12.9. So we're going to cut it just over 13 inches there. What I'll do is, let's use our 32nd side here. I'll cut it 13 and 1/32 of an inch. And that should give us about 1/8 of an inch to face the ends. I like giving myself about 50 to 60 thousandths per face to clean them up. That's just my go-to number there. So 13 and 1/32. So what we'll do to begin here, we're going to use our 3-jaw chuck, and we're going to get the ends faced to get the material faced to the length that we need to finish it at. We're going to just drill centers at this point to support the shaft for all of our roughing and turning. And what we'll probably start with is the spindle end here. Since this is kind of a short area, I'm going to rough all this in just to this length here, get that roughed in real close, and then we'll flip the shaft around to where I'm chucking on this end will be centered, and then we'll get this side roughed in. And once we get all that roughed in, then we'll go to our finishing of the completed spindle there. I'm going to use the 4-jaw chuck at that point so that we can make sure we get everything indicated nice and true to our centers there. Once we get the outside of the shaft done, that's when I'm going to move on to the hole that goes down through there. We'll get that drilled down through there, and then we'll complete this end here. After the OD there, we'll do our Morse taper. That way we can use our 4-jaw and get it chucked up nice and close there, get it indicated running true, and then focus on our Morse taper there to finish it out. And of course, after that, then we'll go to the milling machine to do our indexing for these holes right here. And you have these 4 holes that's drilled and tapped there, and a keyway there in the center. Yeah, I had a little bit too much stick out there and too deep of a cut, so I'm gonna break that in half, 25 thou. Come back and do that again. I was just taking 50 thou off there. I'm gonna go ahead and we're just gonna clean the OD up, because I can tell where it's chucked there. You've got a little bit of run out here, meaning if we flip this around, chuck it, and face it, the two faces aren't gonna be 100% parallel with each other, so we're gonna try to get as close as we can by skinning an area here true. So we flip it around and chuck that, and then this will be true with the other face. I'm just gonna touch it, and let's just take, how about 15 thousandths. Now we got a good clean surface there that's turned true. That's true with our face. This will not slide any further up into the spindle, by the way. It's too big for the spindle through hole. That's about as far as I got. So, and I don't like jamming in the end. I pull it back just a little. And this Gator truck hasn't been used a lot, still fairly new, so it runs nice and true. Might be fun to stick an indicator on there and see what kind of readout we get. Not quite 1/1000ths run out there, just a little under 1/1000ths. And it should be nice and straight through there, concentric as well. And then once we face the other side there, we should have 2 parallel faces. We'll just clean this side up, and we're going to take it out and then go measure it with our vernier calipers to see where our length is at. Just want to clean it up, about 10 thousandths. That's got it cleaned up. All right, we're past the 9. We are at 22 thousandths, 12.922. So we want 12.9. So we'll touch off and take about 22 thou off there. I'll go ahead and take it back out again. I'm going to measure it and verify it. Make sure that we landed on our face length that we want, and then we'll go back in there, center drill it, and then we'll go ahead and get the first end roughed. What I do, I try to line up the depth of the jaw, that length right there, that step that you would use for measuring the inside diameter. So I just kind of line it up about even with that, and then try to level this side up there as well. And then you're just using feel at that point. You got to rock it back and forth till you get that touch right in the center, and then the same thing as sort of rocking it up and down like that. You don't want to over tighten it, you just want it to touch. And we are at 900, let's see, and 1, exactly where we wanted it. 12 inches, 900, and then the first graduation after the 0 is lined up, so it means 901. We're good to go. We'll go back to the lathe now and start our turning, start our roughing anyway. Before I went into the lathe, I decided I wanted to go ahead and get my sketch made of the shaft here. So that's what I've been working on, is getting a hand drawing made of all the dimensions. And a lot of times when I do these jobs, especially for just one at a time, sometimes I'll just have the workpiece on the bench right here and just go around and just measure. As I'm working on it, I'm measuring it. And sometimes I'll just jot some numbers down so I'll know what my shoulder length is and what my diameter is. On large gearbox shafts and larger pieces, it's easy just to come up here to the shaft and measure it, and then use a paint marker and actually write the actual dimension on there. So that's what I've done a lot on over the years of the larger shafts. But this one, I wanted to go ahead and make a sketch so that I can reference this. I've got my exact dimensions on there. I've got some information for the 2 bearing journals to give me what my plus and minus is to hit those. And that should help me out as we're working on this shaft right there. And then I can also use this to go to the CAD software to help with my practice there, drawing this up in CAD to be able to transfer this to the CNC lathe as well. Now there is some fine details that I don't have every single thing on this drawing. For example, I don't have angles there for the undercuts. That's minor stuff that I can work on as I'm getting to that. I don't have chamfer details on the shoulders there. That's just minor stuff that I can work on as I get to that. But the main thing is that I have my diameters here written down, and I have my shoulder lengths from the end of the shaft. Whenever I'm going to the lathe, I want to know what I'm from the face to the next shoulder, from that face to the next shoulder, and so on. And so it's easy just to have that down, written down there on the drawing there. Okay, so I did make use of my granite surface plate and a lot of my Starrett tools for this. I want to take you in there to the granite plate and show you how I use this to help measure the distances from the end here to each shoulder and get that exactly what you see here. These numbers, this is exactly what I have measured on this, okay? With the exception of the bearing journals. This bearing journal was a little bit small. So I'm going off of a factory spec that it should be for a bearing, and I've got that modified on there, but all of your shoulder lengths and diameters are exactly what this is. My inspection area is really coming together well. I finally have it kind of set up the way I want so that it's convenient to have all my tools in one place and actually have a workbench and have a place for all my tools. So in here on the Sterrett granite plate, and using some of my tools at hand here to help me get this shaft measured in, I've been doing our diameters right here using the V-block to help hold it, and other tools there that we needed to get the job done. So I'll show you how I was using my height gauge here. This is one of the Sterrett digital height gauges that I use to help measure from the end face to each shoulder there down to here, and there's a real small shoulder right here that the bearing goes up against that's 20 thousandths wide. So that's going to be an important one to remember once we turn this journal right here, or that length anyway. So to start with, what I'll mention is that on the ends of the shaft there, I took my stones and stoned the bottom, or stoned the faces, should I say, both of them, try to remove any kind of burrs that's on there. This shaft was actually driven between centers. I can see the 3 witness marks on there from the drive pins. So we've got those smooth, and we make sure that our granite plate is nice and smooth as well without any dust settled on it. And just handle things nice and gently. Don't slam things down. And get this set in place. Now, one thing that I'll point out, I've got my height gauge setting on these 1, 2, 3 blocks. Now these are precision ground 1, 2, 3 blocks that my friend Lance ground for me on a surface grinder. They're matched ground, meaning that they were both stacked next to each other on the mag chuck and ground on all sides, so they are matched. The reason why I had to put my height gauge on a block is because this is a 12-inch height gauge, and our shaft is right at 13 inches long. I think it was 12.9 total, so I didn't have quite enough height there. So we've got it set in place here. I'm going to try to get out of the way so you guys can see it. And you come in here to the end and just really gentle, just come down until it touches. That's 0 right there. That's the last time I zeroed it out. And then we can slide this back and we can keep going down. We can work from this face down to those shoulders, which is a much more accurate and simpler way to get those length measurements versus using a rule and line it up by sight, you know, with the lines on a rule, or trying to hold a caliper there, or even a depth mic. There's all kind of ways to get it done, but this is the way that I wanted to do it this time and make use of my tools here and share that with you as well. So we go down to that shoulder till it just touches. That says 2.939. I believe I put 2.940 is what I got there. And then all of these, I measured all these links right there, got them all in, and they all add up to 2.490. All right. So same thing with coming down here to the base. We just slide this back just enough to clear it, and then bring it down until it just touches that face. 11.108. I got 2 thousandths difference that time, but whenever I was doing my drawing, I got 11 inches 106, 11 inches 108. So we're not gonna fuss around with that too much. But that also helped a lot by trying to measure what the distance is for that shoulder. Right there, that's that step. That's 20 thousandths from this face to that face. Something like that's kind of tricky to measure. So you can get your face measurement here. This is just one way to do it. You can get your face measurement right there. And then you can come up here, take that measurement, come in here to that face, come down there and touch it to get your reading, and then do the math, subtract it, and that left me with 20 thousandths right there. So just a really quick, convenient, easy way to measure something like that otherwise is a little more tricky to get a really accurate measurement on that. All right? So that's how we did that side there. Now, whenever we wanted to flip this shaft over and do the other side, like this right here, the problem is that's a pretty small diameter right there to be setting on the granite plate. Now it'll work, but it wants to kind of rock just a little bit, and it takes it a few seconds for it to settle out and sit flat. So what I did is I used my V-block here to be able to hold that on there. So I'll show you what I'm talking about. Let me set it down so I don't knock it. All right, we've got 1, 2, 3 blocks. These are rubbed on my precision flat stone so that there's no burrs on it, but they are measuring the same, okay? These are just gonna be riser blocks, and then we're gonna use this guy right there. There's just a precision angle plate that you can use on the granite here. Fits really nice, all right? And then I'm gonna use these as risers. Now I'm gonna take, this is my Starrett V block, the 566, all precision ground on all sides there, and then that should square up to the angle plate, and it should be square on the base right there. Push that 1, 2, 3 block back just a little bit. And then now I'm gonna take the shaft and hold it in there and turn the mag on, and that's gonna suck it in there. Now we've got a nice perpendicular shaft, but I don't have to worry about it falling over or bumping into it, so that we can just leave that right there and start getting our measurements that we want over here. So do the same thing. We come up here to the end face where the thread is, and get that. We've got you can see how close it is, half a thou there, so just call that 0. And you can slide it back and then start getting your length measurements there. Come down to that face. 1 inch 22. I've got 1 inch 22 right there on my drawing. Slide it back, go down to the next shoulder there. 1 inch, let's call it 1.3, and that's what I wrote on there, 1.3 right there. The thickness of this, I just used a micrometer here to measure the thickness of that flange. And we have got all of our measurements. So this kind of stuff it's enjoyable to be able to use all your precision tools that you have on hand to be able to get this kind of work done. And it's just fun for me. I like being in here, and I've got a great place to be able to do this now on our granite plate and the nice tool collection that we've been building up to help get this stuff done. For the diameters, like I said, I think I told you, I just laid the V-block down here on the, I just got it on the pig mat. So I use the pig mat to protect the granite plate when I'm not using the actual work surface on there. Just like, I got my stuff here, and pig mat just to lay all your tools on and lay everything on so you're not damaging the face or risk putting any chips in the granite whenever we're doing this. I was about to start turning and actually turn the coolant pump on and realized that my coolant was getting in pretty bad shape, nasty, and I was ready to get this swapped out anyway. So one thing always leads to another around the shop. So I took the time and cleaned out the chip pan, which really needed it. The bottom layer was just really stuck in there bad with all the oil in there, and went ahead and cleaned out the coolant sump underneath there as well. Got everything cleaned out, wiped out really well, and refilled it with some fresh coolant. So now we are ready to start our turning. See if we can do this without making too much of a mess. I want to go ahead and measure this and get our X diameter set on our DRO. Let's try 200 here. I was taking 100. Let's see what this does. I just don't want the chips popping up on me. That's looking pretty good. All right, this is going to be our threaded end right here. We got it roughed. I'm going to go ahead and turn the OD of this area here just to get it cleaned up as well. It sure is nice having some fresh coolant in the machine. Coolant looks so much better than what was in there. Just makes the machine more enjoyable to operate. And that's more than enough turned area there that we need. This is just this area right here that we just skinned. This is ultimately going to be the largest diameter there that's got all the holes drilled in it. We're going to go ahead and get the thread relief machined in there for our 1¼ inch thread. Let's see how this does. We may have to slow this down a little bit. Making use of the DRO, by the way, getting everything set and just watching it. I know I'm going down to 1 inch. 63 is our finish diameter here. We'll stop just a few thou over that. All right. Take this down to the same number, actually our finish, so we'll take it down to 1.063 right there. And we're just going to clean that bottom up back to our 0 right there. Okay, there's our thread relief for the 1¼ inch thread. Actually, I made a mistake there. Not a bad mistake, I just didn't go far enough. I had overcompensated for the tool here. Yep, I need to come back. So I had to take a wider cut, and it's important that this relief is actually machined in here because the chuck, the body of the chuck actually has a set screw that goes down in here and locks in this area, so it's got to be right. All right, there's our thread relief there. That looks right. All right, our short side is roughed in, so we're going to go ahead and flip this guy around and rough in the other side. By the way, I did break the sharp corners there. I always do that just for handling purposes. I don't have a sharp burr there to possibly cut myself on. There's a little side-by-side comparison so you can see, and our undercut that I was talking about, you should be able to see right there. There's some marks in it where the set screws is locked down, locks the chuck down once you get it spun on there. All right, we'll chuck on our newly machined area there. And we've got a nice shoulder to go up against. Just going to very lightly snug it there and go ahead and get our live center in the end of the shaft. Let's see what kind of run out we're getting on our fresh machined area where it's chucked up at. I'm just trying to make sure you guys can see that. I don't know if the glare's got it or not. I'll try it right about there. You can't ask for much better with a scroll chuck. That looks like it's less than a 1/2 thousandth run out. That is awesome. All right, we're going to start turning this area right here. Thought I would talk my approach here just briefly. We're going to start, of course, with the end face, and we will turn to this face right here, the 2.110. We'll turn that first, and I'll come back later and finish out all these small diameters separately. So I'm kind of looking for the first major diameter change, which would be this point right here. We'll get that roughed in to our rough dimension of 22 millimeter. And then we'll go ahead and turn in this, this 0.830 length right here to this rough diameter. And then go from this face all the way down to our major face right there, our end length, which is the 8.168 to our rough finish there, 1.3785. Now, one of the things I have to keep in mind, the way that I drew this right here, this 8.168, if you're setting your Z length and you come all the way down to that face, you could screw yourself up, or I could screw up here because of this 20 thousandths width here where the bearing pushes up against. So this was sort of an error on my part for drawing it that way. And as soon as I did that, I realized this could easily be an error if you're not looking down here and realize you have a narrow 20 thousandth step here that you have to compensate for. So once we get to this 8.168 dimension, I'll subtract 25 thousandths from this to do our end face, and then I'll just finish that face up after we get all of our turning done there. So 1, 2, and 3 major shoulder steps that we'll take as we start roughing in this next part of the shaft. We're ready to start roughing. Get my coolant going here. I've already got my Z and X set for the tool. And we are ready to turn. That is sounding nice. Everything sounds so smooth. I've got this magnetic indicator here that I like to use this as a reference, because when I'm standing here operating the machine, it's nice to be able to look at it and be able to see this reference. You can easily just look down here and line up a 0. But we're also up here on our DRO too. But it's just nicer to be able to keep your eyes focused here and see this come up to your zero approach, versus looking up there away from your cut to line this up on 0. Both work. I'm just pointing out this is what I prefer, but it's good to have 2 of them as a reference there. This is what I want to be my final roughing pass, so I'm just verifying it because I wanted to land on, see if I can get it in there and actually measure where I'm supposed to be measuring it. I was wanting to land about 1 inch 40, 1 inch 46. I can take another 5 there. Our first 2 journals are turned in. Now we're going to do our long journal here. And what I've done is I like to make a witness mark with the tool there as another visual reference as I'm approaching that shoulder. I'm also just taking a quick measurement with the hook rule here, because this width here finishes out at 0.495 inches, and I can see that we're over the 1/2 inch mark there, because we have our 20,000th step that we have to machine in there, plus we have a 5,000ths on each side there for cleanup once we do our finishing. So we've got a 0 down here on this indicator, and we are good on the DRO there as well. We've got our shaft roughed in now, so we can go ahead and begin our finishing process. What I'm doing is that we're just going to let it cool. It's just about there, and then we'll start finishing this area and just keep moving on and getting this finished out. Once we finish this side right here, then we'll flip it back around and finish out that side right there. The lathe did really good. The Precision Matthews, it was nice and rigid. I didn't have any kind of chatter or any problems doing this turning right there. So what we were dialing in 200 thousandths on the cross slide every time. So 100 thousandths depth of cut, 200 thousandths per pass, and 11 thousandths feed rate, and it did fantastic. The more that I use the Precision Matthews lathe, the more that I've been really enjoying how it operates and the rigidity that it's actually offering for these machining ops. Well, we've got the spindle roughed in now. Just letting it, we're gonna let it just finish cooling down some. It's just about there. And then we'll come back and we'll begin the finishing. So we'll finish this here and just keep moving down the line. And once we get all this finished here on this side, we'll flip the shaft back around to finish out the spindle nose side there with the 1¼ inch thread. It's working out really good. My insert's doing good. The lathe is working really well. We got a nice, pretty blue pile of chips right there. Every time I use the Precision Matthews lathe, I'm always impressed and pleased with how the machine is working, how it's operating, the rigidity that it's giving me, and the smoothness of the headstock here. I really love this high range of a gearing right there, just because it does have a nice smooth operation. It's not loud. When compared to running my Victor, usually the fastest I ever run the Victor is around 700, because if I jump up to 900 on the Victor, the headstock just screams at you and it's just loud. This is a nice, quiet, smooth operating lathe, and I just really enjoy it. I have really enjoyed owning and operating my Precision Matthews lathe. That should have been our finished pass here on this journal. Right on it. We were looking for 747, 747, and 5/10. This one's good, so we're just going to carry on and continue finishing these journals out. I am swapping out that insert with a fresh insert. That was the 4th, or should I say 8th corner used up on it. And I meant to do that before I started finishing this here, and just kind of slipped my mind. So we're gonna swap it out. We have a fresh corner now for the rest of our finishing there. And maybe this will help improve the finish there. So I'm cleaning up our faces. I always leave 5/1000ths to clean the face up. All right, 0.861. That one's done now. This one's gonna be our outer bearing journal. I'm gonna try to shoot for about 1/1000ths over so that I can file and polish that down to our finished size. Taking approximately 20 thousandths per pass here to land on our finish. All right, finished cut. That's going to be 10, 11, 12, 13 thousandths for our finished cut. Looking for 986. We have 986. Looks like maybe 1/10 under that. So this will give us just over 1 thou that we can file and polish this bearing journal to size. All right, so for our larger journal right here, we have this undercut, and I want to machine the undercut first because this diameter is different than our bearing fit, even though they're very close to the same. So we'll get our undercut done and then finish this one and finish that one. First thing I want to do is just make me a couple marks with the threading tool so I'll know where we need to go in an undercut. So we're lined up with the edge there. Our first length is going to be 4.550. Just want to come in and touch it. That's our witness mark. All right, our length is going to be 2.677. Now we have a couple witness marks there that we can use to just visually go up to. That's not a real critical thing on if this goes past a few thousandths either way. It's just an undercut for, I thought there was a, well, the set screw gets locked in out here, so I'm not really sure what this is for right here. But let's get her undercut anyway. I'm going to work this one just with the cross slide here, setting a 0, because I don't want to change my values on the DRO from where we're already at. We're going to go in about halfway. Just watching it to come up to that line there. I will not do that on our finish pass, which I'm going to try to make this our finish right here. This is being an undercut, so let me get a measurement on it. Okay, here's our finish. .359 and a half. Half a thousandth's big, but that's good. Just an undercut there. Let's see if we hit our mark. I was shooting for 375 and a half. That right there is 375 and 7/10. 375 and 8/10 right there. We got about a 1/10 taper through there, which isn't bad at all. So same thing with this. This will give me room to use some emery paper to bring this down to our finish size. So one more journal to finish there, plus our little 20 thousandths wide step. Get those finished out. One thing I like to do is write down my journal size that I'm reaching for right there. What was this? So 1.3785 is our maximum. I'm going to shoot for 1.379. And then that's just a reference. And then whenever I'm done with that, I just take a little bit of cleaner on a rag, wipe that off, and write my next size, 1.379. That's my target. That should have been my finished cut. Let's see what I hit. I was looking for 1.379. And I am 1.3795. Okay, so we got half a thousandths plus. So I've got about a thousandths that I'm gonna have to polish off this journal right here, which is totally fine. Hit it with a file a little bit, some emery. It's gonna bring that right on down. But it's better to be a thou over a bearing fit like that than to finish right on it and you can't even finish in that size well. So that's done. All we got left is that 20 thousandths face little step there on the face. What I did was I set my X on 0 where I wanted to finish that diameter, and I was exactly on 20 thousandths off that face. So we just made that in one cut and brought our tool down to our 0 on X. Just got to turn this diameter here. There's that pretty finish that we want. That's never fun. All right, we want this one 2.7. 19 thousandths. Okay, there's our finished ODs. Just check this, make sure I landed on it. We are right where we want. Okay, we've got some chamfers to do. Let's see, I've got to do a little undercut on this journal right here. Need to do a thread relief, and then we can go ahead and thread this for our 22 by 2.5. For this radius thread relief there, we've got the perfect insert for that. We'll use our Walter threading tool here. Take the thread and insert out. That's a 1/8 wide radius tool there.